All right, let's look at the probability. All right, so probability of an event is defined by this fraction. All right, so this notation is the number of outcomes in event E over total number of outcomes in the sample space. All right, so note that the probability of the sample space is going to be, of course, 1, right? Because one of those things have to happen. And the probability of an empty set, so probability of nothing happens is 0, right? All right, and when we talk about probability, we make this following assumption for theoretical probability. There's something called empirical probability, which is based on collected data. But the probability we're talking about in this class would be with this assumption. This is called the equally likely assumption. Right? So assumption is that each outcome in a sample space is equally likely to occur. Right? So for example, right, so let's say we're tossing a coin twice. Right? All right, we have the sample space. We have HH, HT, TH, TT, right? So you can see that the probability of getting head-head is exactly the same as the probability of getting HT, head-tail, and same as tail-head, same as tail-tail. And as you can see that it's just a 1 out of 4 possibility, so it's going to be the probability is 1/4. All right, so this assumption is there, so equally likely each outcome is equally likely to occur. All right, then we can talk about probability here. So let's say we have event tossing at least one head. All right, so we know that okay, so one head. So this you can do head-head or head-tail or tail-head, and tail-tail is the only one you have to exclude. So we know that the event E is simply collection of those 3 outcomes. So you have head-head, head-tail, or tail-head, right? So we got that. All right, then since we already introduced the random variable, so I'm going to define random variable as the number of heads tossed, right? So it counts the number of heads. Right, so if you're looking for example, the probability of tossing at least one head, right? So we can do this. So that's the event E, right? So probability of event E, right? We can describe the same probability using the random variable. Right, so we know that the x keeps tracks of the number of heads, so at least one head. So we have a greater than or equal to 1, right? But this is pretty easy to find because here this is defined to be number of outcomes in the event E over number of outcomes in the sample space S, right? Right, you have 1, 2, 3 outcomes in the event E, and a sample space have 4 outcomes, right? So the probability of tossing at least one head is 3/4, right? That's how you find the probability, right? That's it. I hope that this was clear.